You've probably heard words like AI, machine learning, large language models, and maybe you've nodded along without really knowing what any of it means. Don't worry, nobody explained it to you properly. That changes right now. In this video, we're going to break down 6 core AI concepts in plain English. No jargon, no coding, just clear, simple explanations anyone can understand. Let's go. So, what actually is a large language model? Let's start with the word language. AI doesn't understand the world through eyes or feelings. It understands it through words. Billions and billions of words. A large language model, or LLM, is basically a program that has read an enormous amount of text. We're talking books, websites, articles, forums. More text than any human could read in 1,000 lifetimes. And from all that reading, it learned patterns. It learned that after the word good, the word morning often comes next. After the sky is, you usually get blue. It learned how language works. So when you type a message to something like ChatGPT or Claude, you're talking to an LLM. A model that predicts and generates language based on everything it's ever been trained on. Think of it like this. Imagine someone who has read every book ever written. When you ask them a question, they don't think from scratch. They draw on everything they've ever read. That's what an LLM does. Here's a question. How does AI actually read words? Computers don't see letters the way we do. They work with numbers. So something has to turn your words into numbers first. That's tokenization. When you type a sentence, the AI breaks it into small chunks called tokens. A token might be a whole word or just part of one. For example, the word unbelievable might get split into yuan, believe, and able, 3 tokens. Then each token gets turned into a number. So your message becomes a long list of numbers that the AI can actually process. When the AI replies, the same thing happens in reverse. It picks numbers, converts them back to tokens, and tokens back to words. You'll never see this happening. But every single word you type goes through this process in milliseconds. It's like the AI's way of reading. Okay, so we know AI turns words into numbers. But here's the clever part. Those numbers aren't random. They're designed so that similar words end up with similar numbers. This idea is called vectorization. A vector is basically a list of numbers that describes something. Think of it like a location on a map, but instead of just X and Y coordinates, a word might have hundreds of coordinates that describe its meaning. So the word king and the word queen would be close to each other in this number space. And both would be far away from the word car. There's actually a famous example in AI. If you take the vector for king, subtract man, and add woman, you get a vector very close to queen. The AI has actually understood gender as a concept just through numbers. This is how AI understands meaning, not by reading like a human, but by mapping words into a mathematical space where similar things live close together. Here's a challenge. Read this sentence. The trophy didn't fit in the bag because it was too big. What does it refer to? The trophy, right? Not the bag. You figured that out instantly. But how? You paid attention to the context around the word it. This is exactly what the attention mechanism in AI does. It teaches the model to look at every word in a sentence and ask, which other words should I focus on to understand this one? So, when processing the word it, the model gives high attention to trophy and less attention to bag. It learns which connections matter. Before attention was invented, AI struggled massively with long sentences because it processed words one at a time and forgot context. Attention changed everything. It lets the model look at all words at once and understand how they relate. This was one of the most important breakthroughs in modern AI. Everything you use today, ChatGPT, Gemini, Claude, is built on this idea. How do you teach an AI? The traditional way was to have humans label data. Show the AI a picture of a cat. Tell it this is a cat. Do that 1,000,000 times. This is called supervised learning. Humans are supervising and labeling everything. But that's incredibly slow and expensive. You need people to label every single piece of data. Self-supervised learning is a smarter approach. Instead of labeling data, you let the AI teach itself by hiding part of the information and asking it to predict what's missing. For language, this works like this. Take a sentence, cover up one word, and ask the AI to guess it. The cat sat on the blank. The AI guesses Matt. If it's right, great. If not, it adjusts. Do this billions of times across billions of sentences, and the AI gets incredibly good at understanding language. No humans needed to label anything. The AI creates its own training exercises from existing text. That's why LLMs could be trained on the entire internet, because they didn't need someone to label every page. It's a bit like learning to read by filling in blanks in a book. You get better just by practice, not by someone correcting every word. How we put it all together. All of these ideas, tokenization, vectors, attention, self-supervised learning, they're all combined inside one architecture. One type of AI model design. It's called the transformer. The transformer was introduced in a famous 2017 research paper called Attention is All You Need. And honestly, that title says it all. The key insight was that attention alone was powerful enough to build incredibly smart AI. Here's what a transformer does when you send it a message. First, your words get tokenized and turned into vectors. Then, multiple layers of attention run across all those vectors, each layer figuring out more complex relationships than the last. Finally, the model generates a response, token by token. Every major AI you've heard of is a transformer. GPT, the G stands for generative, the T stands for transformer. BERT, Claude, Gemini, all transformers under the hood. Before transformers, AI was good at small tasks but struggled with long, complex language. Transformers basically unlock the AI we have today. It's that important. So next time someone says, the AI understood me perfectly, that's a transformer doing its job. So that's the first 6 concepts, the actual foundation of how AI thinks and learns. You now know what an LLM is, how tokenization works, what vectors do, why attention was a breakthrough, how AI teaches itself, and what a transformer actually is. In the next video, we'll go deeper, fine-tuning, prompting, RAG, agents, and more. Drop a comment if any of this clicked for you, or if you want me to go deeper on anything. Subscribe if you want the rest of the series. See you in the next one.